Now let's look at another useful operation, taking derivatives. So suppose a of x is our generating function for a sequence an. If we differentiate this term by term, so the x to the n is going to go down and this becomes n an x to the n minus 1, right? So if we differentiate this term by term, we get that the derivative of our generating function is given by this. And sometimes it's if you want to make it look nice, you can just multiply by x on both sides so that this just aligns here. And so differentiating a generating function has the effect of multiplying the coefficient an by n essentially. And so this can be useful when trying to find generating functions. Let's do an example. So let's use derivatives to find, again, the coefficient of this here. So in a previous video, we showed how to find it with convolution. And now we're going to show how we can find this ak here using derivatives. So here, if we take the derivative, so think of it like this. If we start with our 1 minus x that we already know the generating function for, so we know that this is a generating function for the sequence of all ones. If we take the derivative of this on both sides, so on one side the derivative of this is going to be what we're interested in, the 1 minus x squared. Now the derivative on the right, we can apply it quite simply. We just differentiate term by term and we get this nx to the n minus 1. And we can then just shift this to rewrite it in this way over here. And that means that we get the same that we got before. So the generating function, so this function here is the generating function of the sequence k plus 1. So ak equal to k plus 1 has this over here, which we saw before also by doing convolution. So this shows a different way of doing it by using derivatives.